Okay. Okay, so I'm here to chat about revolution or evolution of science, however you want to look at it. Yes, I'm learning to fly, but I'm also a journalist, and I also run an organization called Science Disrupt. So I'm all about trying to do science in different ways, more efficient ways, kind of a little bit more startup-y, a little bit more Silicon Valley-esque. Whether that's writing about science startups or whether that's connecting up entrepreneurs with government and with academics at the same time. So I want to make you guys super excited about what's happening in the world of science and kind of how we're trying to learn a little bit from this amazing tech startup scene that we've been witnessing for the past couple of years. So I don't know if anyone here has ever Googled image search, the word technology, but this is what you get. So it's not the best representation, but at least you get this idea of future and silver and gold and interactive, and it kind of looks kind of exciting, right? This is what you get when you Google science. Right? I mean, I love science, and this is so sad. It makes me feel like I'm going back to school. It feels really naive. It doesn't really feel like something I want to associate with. You know, I want to be cool and future and silver. I don't want to be clip art, okay? So I think we can agree that science has a slight issue when it comes to perception. And I think that's something that quite a lot of people are quite aware of. But I want to tell you a little bit about some of the other issues that science has that I think the world of tech and startups can really benefit and help with. So the first one, I guess you guys are probably all aware of this kind of image, a hackathon, a place where you're getting coders and lawyers and designers and policymakers and people off the street and whoever has ideas to come together and solve a huge problem. In science, you have the history department at one side of town and the chemistry department at the other, and they don't really find a need to talk to one another. This is a totally alien concept when it comes to academic research. What about this? The idea of being able to self-teach things like coding or digital skills or learn how to do machine learning online in a really short space of time. Science isn't like that. You normally have to do a 4-year PhD from a particular kind of institution and publish in particular kind of ways. We don't have this sort of self-starter thing. Let me give you another example. GitHub, okay? Everyone knows about this magical place where people share their ideas, their code, they ask for feedback, they want people to get involved. I mean, we've just heard from IBM Watson, this is how they share how to get involved with the Watson technology. They make it super obvious and welcoming and easy to an extent. This is the front page of the most reputable journal in all of science. This is the content page. It's not exactly very welcoming, is it? And when you do find something that you want to read and you want to learn from and you want to do something with, this is what it looks like. So, science has got some real issues when we think about trying to collaborate and try and do things differently. I actually edited this, see where it says abstract? That's actually cut in the screenshot. There's a whole load of other names and institutions before you even get to the abstract, which is the summary. It's totally mental. Not to mention that most of these are behind a paywall, but that's another story. So, can science learn from tech? The answer is yes, and I think what I want to talk to you guys about is a little bit about what these things are that science can learn. So I kind of see it as tech having these 4 key attributes, or at least this tech startup scene that we kind of keep talking about. One is of openness, so we've already kind of touched on that, this idea of being able to share your code, your ideas, people coming up on stage and talking about things and wanting to get people involved. I mean, look at IBM coming up and going, here are all my links, come do stuff. It doesn't happen in science. Collaboration, you don't need to be in the same room to do something. We've got Skype and cloud services to build things together. Not always the same when it comes to science. This DIY mindset, this just effing do it, this find a way, make a way, this we'll just build it, don't worry about it, we don't need an expert, we'll find a way around it. Again, something that's not massively known in academia. And this kind of 4th one, which hopefully I'll be able to highlight a little bit in this presentation, is this idea of big thinking. So, you go to these big tech conferences and you get someone go on stage and be like, we're going to go to the moon, or we're going to do this amazing thing and whatever, and it's inspirational and you feel good and you think, wow, I'll put my money in Elon Musk or Mark Zuckerberg or whoever the person is that's presenting. And science is not like that. Science is very incremental. If you think about it, if you were a scientist 200 years ago, you were a scientist. And then if you were a scientist maybe 100 years ago, you were either a biologist, a physicist, or a chemist. 50 years ago, you were a microbiologist or a chemical physicist or an astrophysicist. And now, you'll be a computational biologist focusing on cell mobility and Drosophila. Okay? We don't have this idea of going for these big ideas. It's all about being really, really incremental and trying to get new insights. So how do we foster this idea of big thinking and try and make things happen with science? So I focus on a few areas. I want to take you through each of them and show you some of the stuff that I'm really excited about, people who are doing amazing things in this world of science innovation. So I don't believe we should just complain. I think we should, champion people who are doing awesome stuff. So hopefully I'll excite you with some cool science stuff, and we'll all feel good about ourselves when we go home. Okay, so the first area is space. Everyone loves space, so I thought I would start with that. And the first company that I think are doing amazing things is one called Open Cosmos. So for anyone here who doesn't launch satellites into space, I'll give you a little insight. It's extremely expensive. It's very difficult to do. There's a lot of admin. There's a lot of law to go through. You have to be able to basically be in the good books of someone like NASA or the government or a really well-funded company. Open Cosmos are a tiny startup out of London. They just finished the acceleration process in a small accelerator about 2 years ago. And what they're doing is they're creating these little CubeSats. They're about this size. And they're allowing anyone to put their experiments onto one satellite. So they'll pile up lots of different experiments onto one. You send that in, and then they go off and launch it for you. And then what you do is you track your data on an online platform. So it means that anyone in this room could propose an experiment or say, I want to gather some kind of data in the stratosphere, and you can do it right now for super, super cheap. We're totally democratizing access to space. And I'm saying you could put a satellite in space. You'd be like, why on earth would I want to put a satellite in space? Well, say you want to predict if there's going to be a flood in a certain country next week. You need space data. Say you're a farmer and you want to know when you should do your harvesting. Space data can help with that. Space data is so rich. So yeah, Open Cosmos is doing amazing, amazing things. Another company which you might have came across is one called Planetary Resources. So they want to mine asteroids. Let me just sink that in a little bit. Asteroids that are orbiting our Earth, they want to land on them and mine them. What the hell? That's awesome. But the reason they want to do this is they're convinced that the reason we haven't done enough human expansion in space is because of a lot of limiting factors. The first one being we need a lot of water to survive, and it's not sustainable to launch water up with a rocket. So you need to find a way of gathering water once you're in space. Asteroids are full of water. You can also use water for propulsion, hydrogen explosions to push your spaceship even faster. You also get lots of really great minerals and metals and things, so you could, use it as a, cement or whatever, if you wanted to build some kind of space retreat on the moon or something. This is genuinely what they're doing. They've got their first big mission going in 2020 when they're basically going to analyze all of the asteroids so they can work out which ones have the most water and the most metals. Crazy. You'd think this would be something with NASA, but no, it's a private company, startup. Okay, enough of space. I want to move on to energy. So the reason that I cover energy is if you think about it, every single thing that we do in a sort of, first world country has something to do with energy. This whole room, we can't do anything in here without energy. My presentation doesn't work, my mic doesn't work, your phones don't work, you can't get home with any kind of transport. Energy is literally at the root of whole of modernity, okay? But as you all know, it's kind of an archaic system. It's really difficult to change things. You've got so many stakeholders. You've got government, the big companies. You've got the users. You've got the lawyers. You've got so many things you have to change in order to do one small thing. So who's trying to change this? Well, it's normally scientists. So here's one company, for instance, TerraLoop. They're totally revolutionizing the way we store energy. So we're talking a lot about renewables, which is obviously awesome. But the problem with renewables is that you can't moderate them very well. So for instance, if you have a solar panel, it'll gather a lot of energy during the day when it's sunny. But you guys are all at work, and you don't need any energy in your home. So when you come home and it's not sunny, and the solar panels aren't gathering anything, you want to tap into that stuff that's been stored. Same as with wind. You can only gather on a windy day. What happens if you need energy when it's not windy? So storage is a real problem because batteries are really inefficient, they're super expensive, they're really bad for the environment. So everyone's trying to crack this idea of storage. How do we store energy in a better way? And TerraLoop have basically come up with this prototype where you have a 100-meter diameter circle, a big, massive tube. You think about 100-meter diameter, that's longer than this building. Just the cross-section of the circle. And they bury it in the ground, and they whiz energy around it. Instead of storing energy in a battery as a chemical, it stores it kinetically. So it's moving. Just keeps going until you need it. Mental. And they're doing prototypes right now, installing them with wind turbine bases and then in cities and transmitting in between. Cracking stuff. This is another company I absolutely love, Mandulis. They're doing a whole load of work in Uganda around trying to create new ways of creating energy. It's a really inefficient grid. There's lots of power outs and things. So doing lots of stuff with like biomass, changing old trees and things into fuel, which is awesome. But then they went and spoke to Imperial University in London, and they created a thing called modularity grid, which is basically creating a blockchain system to create a market for energy. So say, for instance, you're a small business owner and you have some solar panels, or you have a wind turbine, or you have whatever kind of way of gathering energy. You use whatever you want, and then if you create extra, you can sell it. Anyone can do that. Anyone in this room can do that if you have a market, if you have a good blockchain system for selling and trading this energy. And that's what they're creating. They're doing it in Uganda, and everywhere else in the world is going to learn from that. Okay, super awesome stuff coming out of Imperial University research. And the final one that I love in energy is a company called BioBean. It's another London startup, two scientists, and they found a way of turning old coffee grounds, used coffee, into biochemicals and biofuel. So they've partnered with Costa Coffee, which is a big chain in the UK. I don't know if you guys have that here, sorry. It's kind of like Starbucks. And they went around Costa and they started gathering up all the used coffee, which normally Costa have to pay to get thrown away. It's quite expensive. They gather it up, they take it to the plant, they turn it into energy, and they sell it back to the grid. Super simple, massively sustainable. And again, it had to come from a chemical process that they've, IP'd and so on and so forth, turning coffee into energy. And there's loads of things. You can do this with hazelnuts, you can do this with trees, you can do this with lignin, so many different things, but most of the stuff stays in the lab. The commercialization of it isn't always happening. So good on them for managing to do it. Okay, so the next one. We've talked a lot about AI today, so I'm not going to stick on this topic for very long, and instead I want to talk about quantum computing, which I'm super excited about. For anyone who doesn't know what quantum computing is, I'm not going to do a big primer, mainly because I'll probably muck it up, but it basically allows you to do multiple things with the same computer at the same time. So you can massively heighten your output and do things that computers nowadays cannot do. So there's a company called Rigetti. They were part of Y Combinator 2 years ago. And normally, quantum computing is only done by people who have a lot of money, because it's super expensive to try and make any kind of hardware in quantum, mainly because you have to keep it really, 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 really cold. So it uses loads and loads of energy in order to just create this hardware. So normally it's done by places like, Oxford University or MIT or IBM or Microsoft, and Google, places that have a lot of investment to put in this research who will get a massive return if they manage to hack it. But this high barrier to entry normally stops any kind of company that doesn't have loads of capital from doing it. But not Chad Rigetti. He used to work at IBM. He then went and raised. He pushed people and was like, we can do this. If we do it faster, we can get better engineers. We can pull our resources together. And not only will we create hardware, we'll also create software. So he managed to get funding, and he's now 3 years in. And they're looking like next year they'll start releasing their first results, which is probably going to be just behind Google, which is insane when you think about a small startup being able to compete with these sorts of companies. So definitely keep an eye on those guys. Okay, health. Everyone's interested in health, I guess. I want to try and keep it back to the sort of academic side of health and a little bit about what we're doing in science, because I know there's a lot of really great tech applications in this space that you've probably already heard of. So the first one, I want to introduce you to my friend Shafi. He's awesome. He's a surgeon out of London. If you haven't already heard of him, I urge you to go and look him up. He's super inspiring. He is a cancer surgeon, and he live streams his operations using Snapchat Spectacles or Google Glass, or he sometimes gets people to do it with a 360 camera and then beams it across Google Cardboard. And the reason he does this is because training surgeons is a really difficult process. The way they do it goes as follows. You have an expert surgeon, which is me. I will have my 10 trainees around me, and I'll say, come on in, let's go do an operation, la la la. And they'll be the patient, and the expert surgeon will be doing the surgery, and they'll be saying, this is what I'm doing, and I'm going to do this. And all the trainees go like this. right? That's how you train 10 surgeons, and they've got to be in there for like 3 hours. Well, what about training 100 surgeons? What about training 1,000 surgeons? It's not scalable at all, and we've been doing it the same way for hundreds of years. So he beams it, he live streams it, and he's all about trying to get surgical training to countries that don't have really great medical training. He's now developing with a company called Medical Realities. I should have put on the slide, apologies. Medical Realities is the name of it, it's awesome. They're creating virtual reality experiences where you actually have an avatar and you use robotics, and you are the surgeon, so you can train in the virtual environment, get feedback, so on and so forth. Amazing way of totally changing the way we actually teach new recruits. I want to talk a little bit about early diagnosis, which is totally different, I'm sorry, but I forgot to put a slide in to kind of say that I'm transitioning onto something else. So when it comes to any kind of disease or health-related things, there's lots of things that are preventable, so you'll see there's a lot of innovation in health trying to stop you from getting ill in the first place. But the next step beyond that is about diagnosing at a really early stage, because if we can catch things early, we're much better chance of being able to solve them. But the problem is with early diagnosis, some people don't go to the doctor, sometimes it's really difficult, sometimes it's really expensive. When I say difficult, sometimes you need loads of sample in order to see something. So a lot of people are trying to change this. A lot of people are trying to build their own ways of diagnosing, particularly for countries that can't afford big, massive machines to do diagnosis. So this one, for example, called Pocket, they've created this credit card-sized device, really thin, and it's about trying to find any kind of disease that's been brought on by a tick biting you, the little bug. And you literally just prick your finger with the blood, kind of like if you have diabetes. You sort of go like this against the card, and the blood runs along a little route, and at the end of it, after 10 minutes, it tells you whether or not you have some kind of disease that's tick-borne. Incredible. At the moment, people don't even think to go to the doctor, and it's like way too late. And the idea of what they want to be doing is, instead of thinking about diagnosis as going to the doctor and it being this whole big palaver, it's more like going and buying a pregnancy test. Something to note here, these guys don't even have a website. You know, they are a company, they are a startup, they are doing this, they have a prototype, they have funding, and they don't even have a website. Their Twitter has like 3 followers. You know, science. So this happens all the time in science. I'm very privileged I get to meet these cool people, but I would love more people to know about them so that they could scale. Another example of this is the disease diagnostic group. They're out of MIT. They're doing similar sort of thing with malaria, but except they've got this device that uses literally refrigerator magnets and a laser pointer, kind of like, oh, whoops. Oh, I pressed the wrong button. This is a new clicker. Kind of like a laser pointer, so just one like this. This cost me like nothing off Amazon. So anyway, they're managing to ship these out to places where malaria is kind of really prevalent, and they're already seeing results. Again, frankly, a terrible website. I don't even think they're on Twitter. It says they are there, but I don't think they are. And I met them the other day and asked them for a card, and they didn't have a business card. But awesome stuff that these guys are doing, so check them out too. Okay, final little bit is all about research. And what I mean by this is, how do we actually change how we do research in a lab? Not just taking the science out and doing something amazing with it, but how do we actually make the process of being a scientist better, faster, stronger? So the first one I want to shout out is Helsinki Challenge. This is a collaboration between all the universities in Helsinki, and they've also collaborated with the UN and their global goals. And what they've done is they've basically said, okay, we're going to focus on 3 of these goals per year. We're going to find professors within all of our universities that are doing things relevant to solving some of these goals. We're going to give them a business person, and we're going to spin out work. Massive amount of support from the university. Instead of a professor just going, I'm doing this thing, and maybe we could do something with it, they're approaching them and going, how can we make this happen? That's unheard of within universities. It just doesn't work like that normally. So they're doing some really awesome things. That's where I met Pocket. They've got like some people doing like a 3D printed kidney. It's mental, the stuff that they've got going there. And they're really trying to commercialize, which is awesome. Another example is the Engine by MIT. What they're doing here is they're basically allowing new startups to use MIT's research facilities. One of the big problems with deep tech, the science startups, is they need access to research labs, equipment. It's super expensive. So MIT basically have created almost like an Airbnb, but for their equipment. And they'll say, oh, you can rent it this amount, blah, blah, blah. They give them connections to entrepreneurs. They also give them funding. So they've basically created a way of incubating science startups that aren't necessarily even from MIT. It's super, super impressive. And I said a little bit about doing science better. This is a company called Transcriptic, and this is their shipping container-sized robot lab. So it's based in California, this lab here. It's got loads of different things inside. And if I'm a researcher anywhere in the world, I basically go on their website and say, I would like you to test this cell this many times with this kind of reagent, and I'd like my results in 3 weeks. And you click send, you pay, and the robot literally does the experiment for you and sends your data back over email. Mental, right? I mean, biology is normally this. Pipette, 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 for about 10 hours. And then you wait, and then you get your data back, and then you do a little bit of data analysis, and then you go, oh, right, let's change it a little bit. Right, okay, pipette, pipette. This is it's super automation galore, right? So Transcriptic are doing awesome things. There's a few guys like this. And the final example I want to give you, not to do with automation, but the idea of everyone being able to be a scientist, which is a thing, I promise you, is this company called BentoBio. It's a really good friend of mine who's founded this. The little orange and white device you can see here allows you to do genetics on the go, basically. So you can buy this, and you can go out into the field, take some samples, and you can test what's going on with its DNA. Anyone can do this. There's a massive DIY bio kind of community going on. It's trying to get people not to be so scared of this idea of hacking your biology and changing things. Big conversation around GMOs, for instance, is massively changes when you start playing with biology. And these guys, they were funded in Kickstarter, and they should be shipping in the next month or so. So super, super exciting. So there's a lot of examples. I hope that you kind of understand the point I'm trying to make around this idea of if science starts to employ some of these startup mentalities, these tech mentalities, look at the amazing things we can do. You know, I absolutely love, love, love science so, so much, but it's so riddled with problems. And let me say that differently. There's lots of opportunities for awesome people to try and change it. And there's only one way to do that, which is our DIY mindset and just effing do it. So thank you very much.